This is the circumcenter and how to find it. What is a circumcenter? The circumcenter is the point where two perpendicular bisectors of a triangle meet. The circumcenter is the center of the triangle's circumcircle. The circle passes through all three of the triangle's vertices. What is a perpendicular bisector? A line that divides a line segment into two equal parts. It also makes a right angle with the line segment. The circumcircle is a circle that passes through all the vertices of the polygon. A vertex is a point where two lines meet and form an angle and the corners of the polygons. Now, these are the 5 steps that you're going to need to find the circumcenter. So I did the work for you. So we're going to start off with these points, A, B, and C. So we're going to have to find the midpoints of two lines, A, B, and B, C, as we chose.
Dakota did this because finding the midpoint would mean finding the very center of the line, and as the line goes up, it would become the perpendicular bisector, and we're trying to find all 3 perpendicular bisectors. And if you can remember when Dakota was defining perpendicular bisector, it is
a line that divides a line segment into two equal parts. It also makes a right angle with the line segment.
When those 3 perpendicular bisectors cross, that's where we're going to find our point of, that's where we're going to find the circumcenter.
And now, to find the midpoint, you're going to do x1 plus x2 over 2, and then y1 plus y2 over 2. That's going to give you the answer. Now, we plug that in to get -2 plus 1 over 2 and 6 plus -1 over 2. And we got -1/2, 5 halves. And we did the same thing for BC. 1 plus 5 over 2, and then -1 plus 4 over 2. And we got 3, 3 halves. Now we're going to find the slope of the equation, or slope of the line.
Dakota's finding the slope because he wants to find out the measurement of the entire line. So he's going to find the slope of the same lines that we're finding the midpoint for, so we can find the line and the exact center of that same line.
So to find the slope of the line, you're going to do y2 minus y1 over x2 minus x1. So we're going to plug in those points, and we got -1 minus 6 and -1 minus -3. And you get -7 over 3. And we're going to have to use the reciprocal because we're trying to find the slope of the perpendicular bisector.
Now that we have our slope and our midpoint, we need to change the slope so it's our reciprocal, so basically the opposite. So with that, we can plug in our equation and find out what we need.
And then we're going to do the same for BC. We do 4 minus -1 over 5 minus 1. You can get 5 over 4. And then you're going to get the reciprocal, which is -4 over 5. And then you're going to plug that into the equation y equals mx plus b. So we're going to get 5 halves equals 3 over 7 times -1/2 plus b. And you're going to figure out to get b, and we found that b is 9 over 7. And then we do the same for the second equation. And you find out b is 39 over 10. So then you're going to set the equations equal to each other.
Alright, to finish this out, we're going to find these 2 points. Well, we're going to make them equal. So we can set up this equation right here. So now we do our math, and by plugging them in, we can make them equal to each other. So we're going to end up with the number on the bottom that you see, and we're going to end up with this number, turn back to circle, right here. So now, those are our 2 points, and we know that because when we plug it in, it says point right in the middle, equal from all the vertices.
To find the orthocenter, we're going to start with vocabulary. The orthocenter is the point where all the altitudes intersect. And altitude is another word for height. It's a perpendicular segment from each vertex to the line containing the opposite side. And perpendicular is an adjective that describes how 2 lines intersecting create right angles. So for step 1, we are going to try to find the equations of the lines that the altitudes intersect. Because the orthocenter is the point where the altitudes, which are perpendicular segments, intersect, the equation of the line that the altitude is perpendicular to is the opposite slope of the altitude's equation. So to figure out the first step, we are going to find the slopes of AB and AC. We don't have to find the slope of the third equation because the orthocenter is where all these lines intersect, so we know that the third line will just intersect at that point too. Once we've done this, we can find the equation of AB and AC. At our work, we can find the slope of line AB by using the equation y2 minus y1 over x2 minus x1 to find the slope. So when I plug in my points, I get negative 7/3. And then you can plug in one of the points, either negative 2 comma 6 or 1 comma negative 1. And you can get y equals negative 7/3 x plus 4/3. And we can do the same thing for line AC. Using that equation, I found that my slope was negative 2, 7. And when I plugged in 5 comma 4, I got negative 2 over 7x plus 38 over 7. In step 2, we're going to find the altitude equation for the line. So going back to my explanation in step number 1, the orthocenter will be found by finding the reciprocal slope of the line that the altitude is connected to. For example, the reciprocal slope of the line AB would be 3 over 7. Now looking back at the definition of altitude, it says that the altitude connects to the vertex on the opposite side. So we can use the point of the vertex to plug in into y equals mx plus b with the reciprocal slope. Once we're done with this, we will have both slopes of the altitude. So for line AB, the reciprocal slope would be 3 over 7, like 7 my explanation, and the vertex on the opposite side is C, which is 5 comma 4. So when I plug in 5 comma 4 into the equation, I get y equals 3 over 7x plus 13/7. So then I do the same thing for line AC and getting the reciprocal of 7 over 2 and the opposite side vertex thing being 1 comma negative 1. And when I plug that into the equation, I get y equals 7/2 x minus 9. The third step is where we find the actual coordinates for the orthocenter. So finally, looking at the definition of the orthocenter, the altitudes will all intersect at one point, meaning setting the equations of the altitudes equal to each other will give us the coordinates of the orthocenter. First we'll find x, and then we'll plug it in to find y. So the final step, when we set 7/2 x minus 9/2 equals 3/7 x plus 13/7, we set that equal, and we get x equals 89/43, and then we plug in that to 7/2 x minus 9/2, and we get 623 over 86 minus 9/2, or 387 over 86, which equals to 237 over 86, and that can be simplified down to 118 over 43, which is y. So the final coordinates of the orthocenter are 89 over 43, 118 over 43.
So we are going to be finding the centroid, and this is the point where all medians intersect. A median is a segment that connects each vertex with the midpoint of the opposite side. A midpoint is the point on a segment that divides the segment into 2 equal parts. So first what we're going to do is we're going to find the midpoint of line BC. We're finding the midpoint because this is where it will be when it's connected from the vertex. So to do that, you plug into the equation x1 plus x2 over 2, comma y1 plus y2 over 2. So then you do 1 plus 5 over 2, comma, negative 1 plus 4 over 2, and then you get 3 and 3/2. Next, you find the slope between midpoint BC and point A. You're using point A because this is the point that's across from segment BC. So you plug that in to find slope, and you get negative 9/10. And then you find the equation of A and BC. You get y equals 9/10 x plus 39/5. And you're going to do the same thing. You're going to find the midpoint of AC, and you get 3/2, comma 5. And then you're going to do the same as step 2, but with midpoint of AC and point B. For the slope, you get 12, and then when you plug it in for an equation, you get y equals 12x minus 13. Then you're going to set the two equations equal and solve for x. You end up getting x equals 4/3. After you find the x, you plug it in to find y, and you end up getting y equals 3. So the final centroid point is 4/3, comma 3.